We can use our knowledge of slope and the distance formula to classify shapes. And in this video, I will show you how to classify triangles when you're given 3 coordinates and quadrilaterals when you're given 4 coordinates. But before we can do that, we just have to remind ourselves about the different types of triangles and the different types of quadrilaterals. So for triangles, there are 2 different ways that you can classify it. The first is based on the lengths of the 3 sides. So if you're given 3 coordinates and you want to find the lengths, you're going to use your distance formula. And that distance formula, if we need a refresher, is the square root of x2 minus x1 squared plus y2 minus y1 squared. And remember, the distance formula just came from Pythagorean theorem, where the side lengths came from the slope. y2 minus y1 was the vertical side length, and x2 minus x1 was the horizontal side length. That's your rise and your run. And we know for Pythagorean theorem, it's a squared plus b squared equals c squared. And that's why our side lengths are squared, and we have square rooted at the end to isolate for our actual distance and not distance squared. Now, once we find our 3 distances, or the 3 lengths, if all 3 of them are the same, we have an equilateral triangle. If 2 of them are the same, it's an isosceles triangle. And if all 3 sides are different, we have a scalene triangle. So that's one classification. But you also have to classify it as if it's a right triangle or a not right triangle. And to do that, you're going to have to calculate 3 or potentially 2 slopes, and then check for negative reciprocals. Because if 2 slopes are negative reciprocals of each other, that means you have a right angle. And if you don't see any negative reciprocals, it is not a right triangle. So that's for classifying triangles. Do 3 distance formulas and 3 slopes to do your classification in 2 ways. Next, we go to quadrilaterals. Now, for quadrilaterals, we have lots of different types, and we will need to calculate our slopes so that we can see if we have any parallel or perpendicular sides. Because if we have parallel sides, then maybe it's a parallelogram or a rhombus, rectangle, or square. Or if we have perpendicular sides, maybe it's a rectangular square. And then after you determine if you have parallel or perpendicular sides, you've kind of narrowed it down, and then you want to calculate the lengths of adjacent sides using the distance formula. Because if adjacent sides are the same, then maybe it's a square or a rhombus, or if adjacent sides are different, then maybe it's a rectangle or parallelogram. So I'm just going to go through this flow chart and walk you through the steps. So if you're given a quadrilateral, you calculate your slopes. Maybe you see that you have one pair of parallel lines, but the other 2 sides are not parallel. Then you're down the trapezoid path. From there, you want to calculate the length. So you know with a trapezoid that the opposite 2 sides will not be the same. And you can see that from the diagram, the ones that are parallel. But you do want to calculate the distance of the opposite sides that aren't parallel to see if it's just a regular trapezoid or if it's an isosceles trapezoid. If the opposite sides that are not parallel are different, we can just classify it as a trapezoid. But if the opposite sides that are not parallel are equal in length, then it is an isosceles trapezoid. Now let's say for your quadrilateral, you calculate the slopes and you don't have any parallel sides. Then it might be a kite. So that's the only thing that you're going to have to test for. So what you're going to do, you're going to calculate the distances of adjacent sides. You're actually going to need all 4 of your distances here. And if you have 2 pairs that are equal in length, and then your other 2 pairs are equal in length, then you have your kite. And again, no parallel sides. And finally, if you calculate the slopes and you see that you have 2 pairs of parallel lines, then it might be a parallelogram, a rhombus, a rectangle, or a square. Now I want you to remember that the rhombus, rectangle, and square, they're all types of parallelograms, but you have to narrow it down if it is a specific type of parallelogram. You can't say that you have 2 parallel lines, say it's a parallelogram, and then stop from there. You have to go further. So once you calculate the slopes and you notice your 2 pairs of parallel lines, you also want to check to see if you have perpendicular sides. If there are no negative reciprocals, then you know it has to be a parallelogram or a rhombus. However, if you notice that you do have negative reciprocals and you have those right angles, then you know it's a square or a rectangle. Now, you have to narrow it down between parallelogram or rhombus or rectangular or square, and that really depends on the lengths of the adjacent sides. If they are different, it's the parallelogram or the rectangle. If the adjacent sides are the same, then automatically the other two sides are the same as well, so it's a rhombus or a square. So let's try this out. And we're gonna start with a triangle. Determine the type of triangle described by the points A, B, C, and we wanna classify the triangle in 2 ways. And I'm just gonna do a little sketch just for my shape, really more to see what slopes I have to calculate. So looking at this, I will start with my distance formula so I can narrow it down with either equilateral, isosceles, or scalene. So I'm going to start with the distance of AB. So I'm going to do x2 minus x1 squared plus y2 minus y1 all squared. And now I'm going to clean this up. So 5 minus 4 is 1, and 1 squared is 1. 6 minus negative 1 means 6 plus 1, so that's 7, and 7 squared is 49. So then we get the square root of 50. Now I'm not going to bother putting this into my calculator because I can just compare the square roots once I found all my distances. So now I'm going to find the distance between B and C. So now I'm looking at these coordinates. So x2 minus x1 means 1 minus 5 squared. Y2 minus y1, 3 minus 6 squared. And now we clean up. So I have 1 minus 5, which is negative 4. But any number, whether it's positive or negative, when we raise it to the power of 2, it is positive. So negative 4 all squared is positive 16. 3 minus 6 is negative 3, but negative 3 squared is positive 9. And when we add those up, we get 25. And this one I am just going to reduce it to 5 because I know the square root of 25 is 5. It's not a decimal or anything ugly. And now finally, I'm going to find my last distance between A and C. So AC, x2 minus x1, 1 minus 4 squared, y2 minus y1, 3 minus negative 1, all squared. 1 minus 4 is negative 3, but negative 3 squared is positive 9. 3 double negative means 3 plus 1, which is 4, and 4 squared is 16. So I see I get that square root of 25 again, which is 5. So right now, comparing my distances, 2 of them are the same. So right away, I know that this is a isosceles triangle. So there's one classification. But I also need to classify it in terms of it being a right triangle or not. So I need my slopes. So I'm going to start with the slope of AB. So y2 minus y1. I'm just going to go to my coordinates and erase what I wrote here so I don't accidentally find the slopes of the wrong things. So I'm doing A and B, so 6 minus negative 1 over 5 minus 4. That gives us 7 over 1. So now I'll do the slope of BC. So 3 minus 6 for the y's and 1 minus 5 for the x's. That's negative 3 over negative 4 or positive 3 over 4. So those are not negative reciprocals. So my only hope is for AC. So for the slope of AC, I'm doing 3 minus negative 1 and 1 minus 4. 3 minus negative 1 is 4, and 1 minus 4 is negative 3. And now, if I look at these two slopes, 4 over negative 3 and positive 3 over 4, those are negative reciprocals, so we have a right triangle. So therefore, triangle ABC is an isosceles right triangle. because we have those negative reciprocals, and that would be my explanation. It's a right triangle because of the negative reciprocals, and it's isosceles because two sides are equal in length. So that's for your triangle. Find three distances, find three slopes. Now, let's try the quadrilateral. The quadrilateral is a little trickier just because you have a lot more options. So first thing I'm going to do is draw a sketch of a quadrilateral. I always assume it's a parallelogram at the beginning, but the only reason I do this is so that when I write down my coordinates, they have to be written in a specific way. And that is, once you label your first one, just go clockwise. So P, Q, R, S. What some people might accidentally do is write P, Q, then jump to a diagonal and write R here. And if you do that, you find the slopes of the wrong sides that aren't actually in your quadrilateral. So I do my sketch so I can see, okay, I need the distance and slope of PQ, QR, RS, and PS. There is no PR or QS that I want to deal with because I don't care about the diagonals. So let's go ahead and start with the slope. And we really want to start with the slopes because that will narrow down our pathway. So I'm going to start with the slope of PQ. So if I look at PQ, I'm going to do y2 minus y1, so 4 minus 0, and then x2 minus x1, so 0 minus 2, and that gives me 4 over negative 2, which is negative 2. Okay, let's go to the next one, QR. For QR, I'm doing 3 minus 4 for my y's, 6 minus 0 for my x's, and I get negative 1 over 6. So right away, I don't see negative reciprocals, so I know there's no right angle because these are the adjacent sides. I just found the slopes of this, and there is no right angle. No right angle. So I already know it is not a square or a rectangle. And that's just me making observations as I go. So now I'm going to do the slope of RS. So negative 1 minus 3 for the y's, 8 minus 6 for the x's, and I get negative 4 over 2, which is negative 2. So right now, I see these are parallel. So let's try one more to see if we have one pair of parallel sides or two. So now I want the slope of SP. So negative 1 minus 0 over 8 minus 2. And what's really important here is that you are using the right coordinates and you don't accidentally mix them up, or else you'll go down the wrong path. And then there we go. We have another parallel pair. So right now we have two parallel pairs with no right angles. So we have concluded, based on those observations, that it is either a parallelogram or a rhombus. And I'm just going to go back up to the pathways here. I know it can't be a trapezoid because for a trapezoid, it only has one pair of parallel lines. If there had only been one, then I'd be here. And if I had none, I'd be with the kite, but I didn't. I am here. And because I had no negative reciprocals, it's not a rectangle or a square because there aren't any of the right angles. So now I just have to figure out the lengths of the adjacent sides. Because if I know one side lengths, because I know I have two pairs of parallel sides, the opposite one is the same automatically. So there's no point me doing the distance formula 4 times. You can, it's just a waste of time. So I'm just gonna focus on the adjacent sides. If they're different, it's a parallelogram. If they're the same, it will be a rhombus. So let's go ahead and finish this example off. So I'm gonna find the distance of PQ, and then I'll find the distance of QR because that's adjacent. So for PQ, I'm gonna do x2 minus x1 squared plus y2 minus y1 squared. Or you could have done the y squareds and the x squareds next, doesn't matter. So 0 minus 2 is negative 2 and squared is positive 4. 4 minus 0 is 4. Squared is 16. So we get the square root of 20. So now let's find the distance of QR. So x2 minus x1, so 6 minus 0 squared, plus 3 minus 4 squared. 6 minus 0 is 6, squared is 36, 3 minus 4 is -1, squared is +1, so that is the square root of 37. Now I see that these are different, so it is not a rhombus. So therefore, PQRS is a parallelogram. And that's it. So you find your slopes to figure out what path you're taking, whether it's the trapezoid path, the parallelogram path, or the kite. And then from there, you can determine what sides you need. If it's the trapezoid path, you're going to check the non-parallel sides. If it's the parallelogram path, you want to check your adjacent sides. And if it's the kite path, you really want to check all 4 to make sure the adjacent pairs are equal.